Yeah, so we're just gonna go through these questions, and then there's also another one here. Like I just hope, I think we do have enough time to go through both of them. So basically, um, in electrostatics, we're only gonna use a couple of formulas, which I think in your case it's gonna be one, and you're gonna find them here. Oh yeah, two. So these are the two formulas that you are gonna focus on for now. And then we also have the value. uh, you don't even have constants for this, so it's fine. So it's gonna be fairly easy as long as you know which formula to use. You won't find this difficult. It's gonna be very nice. So they say a neutral plastic paper becomes charged when it is rubbed with a woolen cloth. After rubbing, the ruler has a charge of negative 3.5 times 10 to the exponent negative 15. So that means the ruler has gained electrons from the from the wool. And they say distinguish between a neutral object and a charged object. So can you tell me, can you try to like describe the difference between something that's neutral and something that's charged?
Okay. A neutral object contains many positive charges,
Okay.
and a positive is a charged object a positive object?
No, a charged object, it's regardless because um I'm not sure if you've already gotten into this, but I think that's something that you're gonna start with next year. Uh,
Excuse me, I didn't hear that. You broke
yeah,
off.
this is something that you're gonna start with next year, but charged objects are not only negatively charged. So it's both positive and negative charges. So so when they say something is neutral, they mean that it has the same amount of negative and positive charges. Nah? So that means the number of negative charges is equal to the number of positive charges. That's when something is neutral. Nah? And when something is charged, either the number of positive charges outnumber the number of negative charges, or the number of negative charges outnumber the number of positive charges. So do you understand that? So when
Yes.
a neutral object, the you're gonna have your positive and your negative, and they're equal. In a charged object, one is greater than the other. So in this case, you can see that the negative charges are greater than the positive charges. That's why this thing is negatively charged. So they say, does the ruler gain or lose electron? So when something becomes positively charged, when you have your atom, né? When you have an atom, I think you guys are using this structure. Um, have you seen this structure? Just gonna draw a circle here. And inside there's gonna be like something like this. Have you seen this? The structure
No.
of the atom. So basically, this is the atom, and here you're gonna have your positive charges and your neutral charges. Eh? So the positive charges are the black, and the neutral charges are the ones in white. Né? And these are going to be your negative charges. The negative charges are your electrons, and they're always moving around your nucleus, which is this thing at the center. So as you can see, we have two that are shaded and two that have a negative charge. So that means this is a neutral object, né? Oh, this is a neutral atom. So now, if I add another electron here, this is also going to be negative, then it becomes negatively charged. But what can happen is that this electron can also be moved to another object. Only electrons move, the nucleus stays the same, but electrons do move out. So if this one does move out and this one also does move out to a different object, this thing is going to end up with one electron now, and it's going to become positively charged. So what that means is that when the ruler is rubbed with the wool, with the cloth, it is gonna gain electrons because its charge before the rubbing was neutral, but now it gained electrons, so its charge is gonna become negative. Do you understand that? If it lost electrons, its charge was gonna become positive here.
Yes.
Okay. So that's how you describe whether something gained or lost electrons. And now they want you to determine the number of electrons that the object that this that the ruler gained. So in this case, we have our equation which says N is equal to Q divided by E. And if you remember well, let me just show you this to you. This is the equation that I'm talking about. And Q is the charge of the object. And in our case, it's negative 3.5 times 10 to the exponent negative 15 coulombs. E is the charge of an electron, which is negative 1.6 times 10 to the exponent negative 19. So I hope you remember this constant, because I know it's not the first time you're seeing it. So here's going to be negative 1.6. And now let's go get our unit for Q. What's this question again? And our equation for our unit for Q is negative. This I need to buy something to help me write these things. So you're gonna have that. Let me take my calculator here. And then that's what we're gonna use to calculate the number of electrons. Uh, and the number of electrons that you're gonna have is 2,000, or 21,875 electrons that have been transferred. Electron.
Excuse me?
Sorry?
Do we just have to type it like that into a calculator to get the answer?
Exactly.
Okay.
It's not, it doesn't have to like have a lot of work. This is just it. You see, it's simple. When you have a 3 mark question like this is all the marks, to be honest. It's a 3 mark question. You're gonna get your first mark for showing for showing this equation. You're gonna get your second mark for the substitution, and you're gonna get your third mark for the answer. You're telling me my internet connection is unstable. And then now we're gonna go to 10.4. They say a charged ruler is brought closer to a piece of paper, and the pieces of paper are attracted to the ruler, as shown below. Explain why the pieces of paper are attracted to the ruler. Yo, man. You see this question? This question is very, very nice. So I'm gonna explain it to you. Or you know what? Can you think can you think of can you think of a reason why the ruler is gonna attract paper after you rub it? So Ikota, can you just think of a reason?
Um, is it because a negative charge um it induces with a positive charge?
Yeah, yeah, it does attract your positive charges. So, but the thing is, they don't tell you that the paper is charged. So here's what's gonna happen, huh? So what happens is that this this ruler is now negative, so that means it has a lot of like free electrons from the question that was seen below. It has like 21,000 free electrons. And then what's gonna happen is that, as you said, these are like positive. These are usually positive. I think the reason you gave is much more simpler. But do you think you can give a reason for 3 marks? Or do you think you remember what I explained to you about electrons, huh? What I
Yes.
explained to you about electrons. So can you try to talk at that scale? Because here, like you just generalized, which is okay for a mark, but you need to like explain it in like an atomic level. You know, can you try that?
Yes. The cone um requires a negative charge, and the paper requires a positive charge. So then they attract each other because the one has a negative charge and the other one has a positive charge.
Ah, 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 that's happen.
Excuse me?
No, 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 no. You are correct. Like all you have to say is that the paper is positively charged, né? And then the ruler is negatively charged. And due to this negative charge, the columns force, you have to actually mention columns force, which is now I don't do they teach you about columns force? You know what? Maybe I'm just going in too deep because I don't think you guys have been taught about like columns law and all that stuff. I think you're gonna learn that in grade 11. So maybe I'm taking this deeper than it has to be. But anyway, I'm sorry, the ruler is negative, the paper is positive. Positive and negative attract. I think that's the best case scenario. So they say, can you describe one application of electrostatics in our daily life? What do you think like this system can be used in like in your daily life? So where you think this can be used? Like any guess? There is no wrong answers.
Could it be when I'm not sure, but like when you brush your hair,
Yeah.
when you brush your hair,
When you brush your hair. Okay, I don't know whether you know about this, but you see, have you seen like um have you seen a chimney?
yes.
So you see these giant chimneys near the factories, né? Where like you see sometimes there's like smoke coming out of the giant chimney or the giant factory. Because now from just where I stay, I always see like this other chimney from afar. Like there's always like smoke coming out of it. So basically, what happens is that you're gonna have something like this. Uh, it's even the shape is slightly like a volcano, and then there's always gonna be like gas coming out of the chimney. So it's the same thing when they're burning, when you guys are using the chimney at home. There's always gonna be what can I say? What can I call it? Impurities. So when you burn when you burn wood, the gas is gonna go out, it's gonna go up the chimney and out into the environment. But when it comes to like the big factories, not all those fumes need to go out and go into the environment like that, because if they all escape, sometimes you can have acid rain, like you can cause damage to like the ozone layer and stuff like that. So basically what happens is that when this gas is coming up, there's this thing there's this thin layer that they put here, and this thin layer uses electrostatics to trap all the unwanted, all the gases that should not be released to the environment and precipitate them. Basically, precipitating them is like it turns them into like sometimes liquid or solid so they can go back to the ground. You know, as you can see, like obviously a solid has a higher density. Most of the time the solid has a higher density than the gas, so you're going to end up with the unwanted gases changing into liquids or solids, and they're going to get stuck here, and the gases that must be released into the environment getting released. So what you can just say is you can just write electrostatic precipitators. That's one thing that they use in the mining industry, and that's something that you use in your daily life, because honestly I can't think of any simpler one. But um has your but maybe if you go through, and also a photocopy uses electrostatics. You can also use, say, a photocopy machine. All you have to do is go through your notes. I'm pretty sure even in that book that you have, your textbook, there has to be like some uses of these things. So yeah, I don't know whether you understand what I'm saying, but you can say electrostatic precipitators or a photocopy machine for this question. Those are the two things that use electrostatics. So are you still with me so far?
Yes.
Okay. So now this one, I think this one is a big question. So they say two identical spheres, X and Y, are suspended by a thread on the ceiling and are held a small distance apart, as shown in the diagram below. And then they say sphere X carries the charge of positive 4 times 10 to the exponent negative 18 C, while Y has an excess of 30 electrons. So they say calculate the charge on Y. So um, I'm gonna ask you to calculate this for me. So if you know your equation, that means N is equal to Q over E, and I'm gonna give you E. E is 1.6. So they tell you that this one has 30 extra electrons. So you already have E. Can you please and you already have E, which is a constant. You already have N, as they've given it to you here. They say it's 30 extra electrons, and you must find Q. Can you calculate Q for me? Okay, not calculate. Can you like just show me how you're gonna get it? Are you using a laptop?
No, I'm using my phone.
Okay, then I think it's gonna be easier for you to like draw here. Okay. So can you try that? Sorry, I'm sorry. Kota, do you understand the question?
Yes.
Uh, can you let me just move these um because I'm like when you're looking at this question, this information is for X, and now we are dealing with this one. You understand? Like it's separate things. So they say they tell you you are gonna look at all the information regarding Y. Our N is 30 electrons, our E is this amount of electrons, and we have to find Q. How about you try? How about the first thing you? How about first you try to make Q the subject of this equation? Can you do that
I first do it in my book and then I write it on the board. On the
on the whiteboard? No, no problem. So let me just even close. Should I close this? Or actually, you know what? I'm gonna give you these 10 minutes until like it cuts off, and then when I'm gonna restart the next one, then you can give me the answer. Is that fine?
Yes.
Okay.
Excuse me? Will the N be 50 electrons? Or hello?
No, I'm sorry. I thought you could hear me. So N is the number of electrons. So N is the number of electrons, Q is the charge of the object, and E is the charge of an electron. So now they want you to find Q, which is the charge of the object, and in our case, it's the sphere. So I hope that helps. Um, so did you get your answer?
Yes, I did, but I did it in two different ways because I wasn't too sure.
So what was the answer? Uh, is it
I
is it negative 4.8
yes,
times 10 to the exponent negative
I did.
18, right?
Yes.
Yeah, yeah, that is the correct answer. So
Okay.
just keep that in mind as we're gonna answer our last question, or as you might have to answer your last question. So they say give a reason why the spheres will move towards each other. Why do you think it's
Because X is positive and Y is negative, so they attract each other.
easy? Easy to marks. Then they say the spheres are allowed to touch each other. After touching each other, they move away from each other. Um, I'm pretty sure I'm gonna have to explain this to you, and I'm gonna show you the calculations. So let's end this so we can come back for our last 20 minutes, and then yeah.